Hi everyone, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher. So everybody, let me know in the chat box if I am clearly visible and audible to all of you or not. And today we are going to start with our next chapter, that is electrochemistry. So till now, for class 12th, we have completed solution chapter, chemical kinetics, and with the end of electrochemistry, we'll be able to complete class 12 physical chemistry. Then we will start with organic chemistry. Okay, so everybody, let me know organic or inorganic chemistry. I want to know in the chat box what you want me to start, right? So yes, Murali, Pavitra, Moon, Abhi. So how are you all? Shall I start the class? Everybody eagerly waiting for your class. Perfect. I'm also eagerly waiting for you guys to join in, and let's start this electrochemistry chapter. See, is from this chapter now, this is one of the most important chapters of your physical chemistry, and sure you are going to see 3 to 4 questions from electrochemistry, right? So it's a very important, very scoring chapter. Every single lecture, every single topic is important for you, right? So in today's lecture, we are going to talk about Daniell cell, electrode potential. We are also going to see the previous year questions, how they are asked based on reducing agent, electrochemical series, all these things. Right, students? Okay, yes, perfect. So firstly, let me see that how many of you have done your homework. And guys, let me know in the comment section as well if you want me to give you chemical kinetics plus solution DPP. If you want me to give you chemical kinetics plus solution DPP, then let me know in the comment section as well after the end of this class, right? Do you want separate DPPs or you want just one DPP for both of them, right? So accordingly, I will make the DPP, right? Okay. So these were the students who have done the homework for chemical kinetics. One is Bharat, then Shiva. Don't worry, Bharat, I'm not going to stop the classes, right? And where can you share the, ma'am, can you share the DPPs of this session? Don't worry, beta, it will be in the chat box or in the, not in the chat box, in the comment section or in the description box, you will see the session PDFs, right? That will be there, right? So you don't need to worry about, every session has their session PDF in the description box as well as in the comment section, right? Okay, yes. Perfect. So let us start. So first is electrochemistry, what we are going to study in this electrochemistry. So see, electrochemistry, as the name states, it is chemical and electrical energy interconversions, right? Study of production of electricity from energy released during spontaneous chemical reaction. For example, there is some reaction happening, right? From that reaction, you want to generate chemical energy, you want to generate electrical energy, or you want to, or you can say, in the use of electrical energy to bring about non-spontaneous transformation. That means from electrical energy, you want to forcefully make those reactions which are not usually occurred by themselves. That means electrochemistry is nothing but if you have a spontaneous reaction. Spontaneous means which will occur by itself. Spontaneous reaction, right? That is, its energy is converted to, because it is happening by itself, right? So its energy is converted to electrical energy. And if you have already electricity is there, right? So that electrical energy is used to make some non-spontaneous reaction that are not happening in usual, but you're forcefully doing it. So non-spontaneous is which do not occur by itself, right? You apply external force to make that reaction happen, right? So electrical energy is converted to non-spontaneous reaction. So that was about your electrochemistry, what we are going to study, right? So based on these two things, we have two types of cell, right? Two types of cell, we have two types of cell. First is you have electrochemical cell, other is electrolytic cell. We are going to study both in this chapter. This is actually a lengthy chapter, right? So one by one we are going to study all of them, right? So electrochemical cell is when you have already some chemical reaction going on, right? Spontaneous redox reaction that is converted to generate the electricity, right? Chemical energy is converted to electrical energy. You can remember chemical energy is converted to electrical energy in electrochemical cell, right? And in electrolytic cell that we are going to study in the end of this chapter. Here you have electrical energy is converted to chemical energy, right? So non-spontaneous redox reaction, right, that is carried out by using some electrical energy, that is called electrolytic cell. Okay, students. Now, ma'am, what is spontaneous? Spontaneous means something that is occurring by itself, right? That is a spontaneous reaction, right? So just you can take an example that digestion, right? You eat food, right? You don't have to apply force to digest something, right? That is a naturally occurring process, right? Photosynthesis, that is a naturally occurring process, right? But if you talk about we generate electricity from, let's say, there is some chemical reaction going on and we are generating electricity from that. So in that case, there is some chemical reaction already going on. We are generating electricity from that, right? But if you have a non-spontaneous reaction, which is like, I don't want to occur. So basically, if you talk about in thermodynamical ways, right, then the spontaneous reaction has delta G negative. And here delta G is positive, right? Okay. So delta G negative is for spontaneous reactions, right? Now, in today's lecture, we are going to focus on electrochemical cell full detail. Next lecture is also going to be on electrochemical cell. Two lectures dedicated towards electrochemical cell, right? So, what is electrochemical cell? We have galvanic cell here, voltaic cell, example is Daniell cell, right? So, we are going to talk about these three things in overall, right? So, let's start this. First thing is, ma'am, one question that might be in your head, ma'am, what is the difference in galvanic cell, voltaic cell or Daniell cell, right? So voltaic cell or galvanic cell is actually where redox reaction is happening, right? We are not specifying certain electrode, right? We are saying that a redox, spontaneous redox reaction is happening, right? From that reaction, when you are generating electricity, right, that is called voltaic or galvanic cell. But in voltaic or galvanic cell, we are not specifying any electrode. But in Daniell cell, we specify that we are using zinc and copper electrode. We are using ZnSO4 solution and CuSO4 solution. So when we specify this thing, that zinc and copper electrode is used, that particular cell where zinc and copper electrode is used, that cell is called, that type of voltaic or galvanic cell is called Daniell cell, right? So you can say one thing, that all the Daniell cells are voltaic or galvanic cell. That means Daniell cell is under the category of galvanic or voltaic cell, but all the galvanic or voltaic cell are not Daniell cell. Daniell is a specific term, right? Voltaic and galvanic is a general term when you have an electrochemical cell. Okay, understood? Yes, everybody understood the difference between what is galvanic cell, what is voltaic cell, what is Daniell cell. Yes, everybody. It has a very high weightage, beta. It has a very high weightage. One of the most important chapters of physical chemistry. It is, right? Okay. So now let's talk about, now things will be more towards the understanding part, right? This is your Daniell cell, right? One thing, that in Daniell cell, one by one, I'll teach you everything, right? Firstly, we're going to focus on the beakers, right? Now, if you see that, what exactly is there, that one thing will be anode, one thing will be cathode. And you have to remember this particular thing here, that is lone, right? That is lone. L means loss of electron. L means loss of electron. L means loss of electron. Then O means oxidation. A means anode. And N means negative electrode. N means negative electrode. That means when I talk about a electrochemical cell, in an electrochemical cell, anode is negative, right? This is a very, very important point, that anode electrode is negative and cathode is positive. Why I have specially mentioned this here? Because usually students get confused in this, right? Electrochemical cell anode is negative, but in case of electrolytic cell, anode is a positive electrode. Cathode is a negative electrode. That difference you have to remember. Don't worry, when we will start doing electrolytic cell in the third lecture, no, then you will get to know about this more detail, right? Okay, till now just remember that in an electrochemical cell, anode is negative and cathode is positive, right? So this anode is negative and this is positive. That is the first thing. Second thing that you should remember from redox reactions, that what is oxidation? Anybody? What is oxidation? What is oxidation? Anyone? And what is reduction? What is reduction? Anyone in the chat box? So oxidation is nothing but it is loss of electron. It occurs at anode, that we know. But how you will visualize that there is oxidation happening, right? So simple way is, here oxidation number will increase, and in this case oxidation number is going to decrease. That is a way of understanding that oxidation is happening or reduction is happening, right? Okay. So how many things we have learned till now for electrochemical cell? LOAN. Loss of electron, oxidation, it occurs at anode, and anode is the negative electrode for electrochemical cell, right? First point. Second is that oxidation is where oxidation number will increase. For example, the charge increases from +2 to +4. That is oxidation. If it goes from +2 to 0, that is reduction. There is decrease in oxidation number, that is called the reduction. Okay? Yes. Right? Now, let's talk about Daniell cell. Right? Because these things were important to know before studying Daniell cell. Now, let's talk about Daniell cell. So, in Daniell cell, they have specially told that in Daniell cell, we are going to use copper and zinc electrode, right? And they have kept anode as zinc. They have specially kept anode as zinc, right? And cathode as copper electrode. As copper electrode. That means this is your zinc electrode, this is your cathode, that is copper electrode, right? Now, what they have done is, in the Daniell cell, this is the zinc electrode. In the zinc electrode, this solution in the beaker is also the sulfate of zinc, that is zinc sulfate, right? That means what we want is, we want that this should be a electrode of some metal, and here you should have the ions of that metal. This is what we want in an electrochemical cell. So here what we have done, we have used zinc electrode. Zinc atoms will be there in the electrodes, and in the solution you will have Zn2 positive ions, right? That is the left part, right? And that is also very, very important to note it down here, that left is anode, left is anode, and left is anode, and right is cathode. Right is cathode. Okay, right is cathode. That is also a very, very important part to remember. Now let's see this. Okay, so this is zinc, this is ZnSO4. Now on the right side you have reduction. That is a cathode. That is a positive electrode which has copper and copper 2 positive ions here. Right. Now tell me one thing. What will happen here? Can you tell me one thing? What will happen here? If you know one thing, that in at anode side what exactly happens? Anybody? At anode side what exactly happens? There is loss of electron or gain of electrons here. At anode side there is oxidation, there will be loss of electrons, right? That you have studied from here, right? That at anode side you have oxidation, that is loss of electron. Now we know that zinc 2 positive will definitely not lose electrons. Zinc will lose electron. Zinc will lose electron to become Zn2 positive and give 2 electrons here, right? And at the cathode part, what will happen? Whenever you have a positive electrode, what happens there? In a positive electrode, what happens, students? In a positive electrode, what happens? You have copper, right? Positive electrode means reduction, reduction means gain of electrons, right? So here it will gain the electrons. Now tell me one thing. Which will gain electron? Copper will gain the electron. Copper will gain the electron, it will become Cu negative, Cu2 negative. This does not exist, right? So that means what is happening here? Copper 2 positive will gain the electron. So that's why what you will write, that copper 2 positive is going to gain the electron to become copper here, right? And that is going to be your overall reaction. That in the overall reaction, what you have is, you have zinc that is getting converted to, see, on the left side you have zinc plus you have copper 2 positive, right? This side you have Zn2 positive plus you have copper. 2 electrons will cancel. Now understand one thing. In a redox reactions, the number of electrons gained and number of electron lost has to be equal, right? So 2 electrons it is gaining, 2 electrons it is losing. Why the strength is so low? Wait a minute, let me just see that. Why the students are not joining? What's the issue, huh? I don't know what you want. Why the students are not joining, huh? What's the issue? Not interested in studying anything? I am waiting for the students to join in, huh? Otherwise, so it's like, whom am I teaching? Am I teaching myself? I already know this. Ma'am, give a break for 10 minutes, please. But the class has just started, huh? So next time I'll make the class at 8:30 p.m. if you guys are exhausted by the continuous classes, right? But today I have already started the class, so please join in, right? Okay? Yes. Very good, very good. Awesome. So, one rod in another solution. Ma'am, what will occur if one rod in another solution of sulfate? No, that thing will not happen, right? That is not an electrochemical cell only. This is the designing of an electrochemical cell. That in an electrochemical cell, especially we are talking about a Daniell cell in specific, right? That the electrode that you are using, the ions also has to be of the same thing. That is an electrochemical cell, right? So that's why we are using zinc electrode. So iron also has to be zinc 2 positive. We are using copper 2 positive, copper electrode, iron also has to be copper 2 positive. Now, this was the overall vision here. Now, let's understand what is happening because of these reactions here. Okay, what is happening because of these reactions here. Now, see one thing, students, just focus here. This is your zinc electrode, right? This is your zinc electrode, or I'll draw it like this. This is your zinc electrode, right? Okay, this is your zinc electrode, right? Now, this is your copper electrode, right? Let's say this is your copper electrode, right? Okay. Now, you have to tell me one thing. Chalo, I'll make this one only, right? Now, see one thing, what is going to happen here, right? Zinc is losing or gaining the electrons. Zinc is at anode side. It is on the left side. It is at anode side. So, it is losing the electrons. Whenever anything is losing the electron, what will happen? What will happen? This will get converted to Zn2 positive and electrons here. So now what will happen? The electrons are going to travel to this side and Zn2 positive ion, extra Zn2 positive ion will be in the solution, right? So what is happening here? This is nothing but your rod and this is Zn2 positive ion in the solution that it will go, right? This Zn2 positive ion will be in the solution now. This Zn2 positive ion are coming from the electrode, right? So because of this reason, what is happening? That electrode of zinc is getting very thin, right? Can you see? Electron of zinc is getting thin because zinc is getting converted to Zn2 positive ion in the solution, right? And this solution is becoming positive and this overall solution is becoming positive because of extra Zn2 positive ions. Because of extra Zn2 positive ion, the solution is becoming positive. Now here what is happening? Here what is happening? You have copper electrode, right? Now in the copper electrode, there is gain of electrons. And from where it is gaining these electrons? From here it is gaining the electron. The electrons that are traveling here, this copper 2 positive ion already in the solution, are gaining the electron to become copper, right? So that means what is happening here? There is increase in the thickness of the copper electrode, right? Copper electrode is getting thickened and the zinc electrode is getting thinner, right? Reason being what is happening here? Copper 2 positive ions, you can write here. Copper 2 positive ions in the solution are becoming Cu, right? Now see one thing. Because of this, copper is getting thick and this is getting thin. This rod is getting thin. Because here zinc is getting eliminated, it is becoming extra Zn2 positive ion here. But tell me one thing, here what will happen? In the solution, what will happen? Because copper ions, right? Let's say you have 100 coppers, 100 CuSO4 molecules, right? Out of that, 50 Cu2 positive ions are converted to Cu. Now you are left with 100 SO4 2 negative and 50 Cu2 positive, right? So what has happened here? Out of these 100 molecules, 50 Cu2 positive ions are getting converted to copper. That means in your solution, you have overall negative charge now, right? So over here, you have overall negative charge. Negative due to conversion of these Cu2 positive ions to this copper, it is being negative in charge, right? Okay. Yes, everybody, welcome to the class. Sacha, yes. Which rod, ma'am? How to know which rod to lose ions and which rod to gain? Firstly, it is not ions, it is electrons that it is losing, right? So this is what I told you here, that one thing you should remember, that for an electrochemical cell, you have LOAN, that is loss of electron is oxidation, and that is at anode, and anode is negatively charged, right? And anode will be on the left side in the electrochemical cell. That's why over here, this is your anode. Here you will have loss of electrons. And here you will have gain of electrons. Is that clear? Okay. Nathan, that will start soon, right? It is soon. It will start. Don't worry. Right? I am just waiting that we should, complete GOC in class 11. But if we are not able to proceed with class 11 GOC, I'll try to do this in class 12 only, so that we can proceed further. Okay? Yes, everybody. Is that clear? That is clear to everyone now. What is Daniel cell? Now, the things that I told you here, we are going to write it in points. But tell me one thing. I have told you one thing here, that this particular solution will become positive. This solution will become negative, right? So when one solution is highly positive, other is highly negative, then the reaction, electrochemical reaction or the redox reaction will stop at one point and the cell will stop working, right? So we also have to come across a solution for this, right? Okay. Now we will come across a solution for this, that is nothing but salt bridge. So can you see here, there is this one thing that is nothing but your salt bridge. This U shape that we have written here, salt bridge, right? So now we are going to understand why salt bridge was needed, right? So let's understand why salt bridge was needed. See, simple thing is, salt bridge is needed to maintain the electrical neutrality here, right? So what we are going to write here, what is salt bridge? Salt bridge is a U shape. It is a junction that connects anodic and cathodic compartments, right? So this is your anodic compartment that connects the cathodic compartment. This is the junction that is connecting. See, it's just like a highway, okay? So this is one road. Let's say this is another road and there is some highway over it, right? That is connecting these two things, right? So that we call it as highway, right? Here that highway is called as salt bridge. It is like a bridge you have, right? That is of salt. Salt means an electrolyte will be added here. It helps maintain electrical neutrality within internal circuit. Now, why electrical neutrality was needed? Because this was actually positive. This was positive and this is negative. And this is negative. Why this solution is positive? Because so many Zn atoms are becoming Zn2 positive. So it becomes highly Zn2 positive ions. It becomes very highly cationic in nature, right? And this is negative. This is very anionic in nature, right? Because so many Cu2 positive ions are getting converted to Cu. Now what happens? You need to balance it. Tell me one thing. If you want to balance a cation, positive means you want to balance a cation. What you will add? You will add an anion or cation. If you want to balance a cation, you want to neutralize, you want to maintain the electrical neutrality here. So you will add an anion here, right? And here you will add a cation. So what we are going to do in salt bridge, we are going to use a electrolyte, and that electrolyte, for example, you have KCl. This is positive, this is negative. So this cationic part always goes to the cathodic side, and this anionic part always goes to the anodic side. That means always cation will be on the anodic side. CC, you can just remember CC. Cation or cathodic side and anion or anodic side. Right? So when from the salt bridge, right, there is K positive, there is the Cl negative ion here, it will neutralize the extra Zn2 positive, right? And here when you add K positive here, that is cation, it will balance out extra SO4 2 negative, right? That is the main work of a salt bridge to maintain the electrical neutrality of the electrochemical cell, right? Now, let's understand what are the conditions for that electrolyte. Now, I am saying that KCl is used. Now, what is the condition that which kind of electrolyte is used, right? So, electrolyte must be inert and strong. Inert means it should not react and give some reaction. It's not like I have added K positive here, it is reacting and giving some new reaction altogether. It will change the entire thing that we are doing, right? So it should not react, right? It's the same thing that it should not react with the mixture here. It should only neutralize it. So it should be inert and it should be a strong electrolyte. That means it should have 100% dissociation. Why 100% dissociation? Because we don't want to overcrowd this solution. See, if it is not 100% dissociated, this solution will be overcrowded with the neutral molecules. There will be no benefit of it, right? So that electrolyte should be dissociated into cations and anions, so that cations I can send to one place, anions I can send to one place. That's why 100% dissociation is needed for us. Second is, the cation and anionic mobilities should be same. That means the speed should be same. Now we will say, ma'am, what is the link with the speed? See, link with the speed is very simple. Let's say here you have added 1 K positive. Here speed is very fast. By that time you have added 3 Cl negative. So how you are maintaining the electrical neutrality? This will be neutral at a very fast pace. This will be neutral at a very slow pace. Right? So what we want is, here you are adding Cl now. If here you are adding Cl, let's say Cl is adding at a very fast pace. This is not real, but let's say it is adding at a very fast pace. And here you have added K positive at a very slow pace. Now, can you see one thing? If you are adding Cl negative at a very fast pace, this will become neutral at a very fast pace. This will take time to get neutralized. So, how come you are maintaining electrical neutrality? Right? So, to maintain the electrical neutrality, the speeds, the mobilities has to be same. Right? So, commonly used electrolytes are KCl, KNO3. These are the commonly used electrolytes that you have. Okay, students, everybody, tell me one thing if that is clear to all of you or not. Right? Now, how the structure, how should be a salt bridge look like? Okay. So first thing is, we are using to make it jellification agent. Jellification agent means we want it to be viscous. Viscous means that it should not be very, very easily dripping, right? So it should be very viscous, so that one drop is going towards one on at a very slow pace we are adding. It's not very fast pace we are adding things, right? So here, glass YouTube, it's not your YouTube that you are watching, it's this YouTube, right? YouTube, ma'am. This is the YouTube. In chemistry, we talk about this is your YouTube, not the YouTube that you watch, right? So this is your YouTube. In this YouTube, you have agar solution, which is also used in in kitchen also it is used. If you have seen those jellies, you must have eaten those jellies, that we used to eat when we were kid, and even now students you eat that, right? So jellies that are in the market, what is added there? Agar solution to make a jelly like solution, so that it gets very viscous, right? So we add agar solution here, right? Agar solution is added, that is usually agar solution, right? With inert electrolyte like KCl, KNO3, these are added here. Okay, students, right? Now, very important part, the direction of flow of current. right? See, we know that this is Zn, right? Zn is losing electrons, so it is electron is moving here. And copper 2 positive ion is gaining electrons, so here electron is gained by this. So that means this is the direction of flow of electron. Now this you must have studied in physics, that the by convention we take that current and electron flow is opposite. Is opposite. So if we say that electrons are always moving towards, if we say that electrons in an electrochemical cell is going from anode to cathode. This is from anode to cathode, right? Then what about current? Current is totally opposite of that, right? So conventional current is going from cathode to anode. Cathode to anode, right? One more thing you can write here. I told you about the thickness here, right? So anode is getting thin, right? Thinner. And cathode is, because it is eating a lot of electrons, right? Getting converted to more and more this copper atoms. So what will happen? It will get thick. Cathode will become thick. Okay? Yes, everybody. Let me know if now everything regarding electrochemical cell is clear to you or not. Right? Everything regarding electrochemical cell, if that is clear to you, then let me know in the chat box, Peter. Everybody, everyone, wait a minute. Everyone. Wait a minute. Okay. Yes, that is clear to everyone here. Right? Current and electrons are opposite to each other. Absolutely right. Okay. Now, let's see this thing here, right? In more detail. See, will the voltmeter fluctuate here or not? Tell me one thing. See, we know that whenever current flows, right? So voltage is generated, that means voltmeter will definitely fluctuate here, right? This particular half cell on the left side is called reduction or oxidation half cells. Here it is losing now. So this will be called as oxidation half cell, where oxidation is happening, and this is called as reduction half cell. This is called as reduction half cell. Always remember AC, anode cathode, AC anode cathode, AC anode cathode. That's it, right? AC you turn it on and just remember AC, right? Okay. This is about how extra ions are being generated, that I have already explained you. Now, what are the observations here? First observation is deflection in the voltmeter, right? That shows that there is current is moving, the electrons are flowing, right? Then Zn2 positive concentration increases. It means mass of zinc rod reduces. That also I told you that anode decreases. It becomes thin, right? And Zn2 positive ion on the anode side, I told you that positive charge will be more. Third is copper 2 positive ion. That means on the right side, you have negative charge will increase. Decreases in this, and that's why SO4 2 negative ion concentration increases. And it means mass of copper rod increases. That means the cathode is increasing. Cathode is increasing, right? Okay, cathode is increasing. Last is both half cells are electrically neutral because of the salt bridge here, right? Okay, students. Now that was your ultimate reaction. This is the full reaction, how it is written, right? This I have already told you, Zn2 positive. Tell me, this will be oxidation half cells. This will be at anode, right? This thing is where there is gain of electron, that is at cathode. That is at cathode. Oh, that is at cathode, right? Where you have gain of electron, that is at cathode. Okay, everything is clear, right? Ma'am, what is potential? Potential, don't worry, we'll talk about potential today, okay? We'll talk about potential. So now, working of Daniell cell overall, but now we are actually trying to see, potential is nothing like voltage in your house. Now we say voltage fluctuation. This you must have studied in physics in more detail, right? I'll tell you about electrode potential in chemistry, right? But let's here first we talk about the external voltage if you apply, right? So there is some voltage because of these flow of electrons, there is some current, and because of the current, there is some voltage that is generated here, right? Now, this voltage is something, right? And you know what is the voltage? What is the voltage of Daniell cell? Voltage of Daniell cell. That also I'll tell you how to calculate, but right now just remember that voltage of Daniell cell is 1.1 electron volt, right? And here we are specifying that if you are saying that the voltage of a cell is 1.1 or something, let's say X, right? X is the voltage of a cell, right? You are applying an external potential which is less than 1.1. No change will occur. No change. Because the external force you are applying is not capable of changing this, right? So now electron flow will be from anode to cathode. Current flow will be from cathode to anode. That is the same thing. Everything is going to remain the same. But let's say your external voltage is equals to the voltage of the cell that you have generated, right? So here we are using Daniell cell. So if your external voltage is equals to 1.1, then what will happen here? Cell will stop. Cell will stop. Cell will stop only here, right? There is cell will not, like cell will stop completely here, right? Okay, so it will not produce more current or electrons. It will stop, right? Third is when you have external voltage is greater than 1.1. In this case, what we are doing, see now here Daniell is 1.1. External voltage you are applying here, that is more than, it's same thing that if you are like someone, if someone else who is more powerful than you, they can replace you. If someone is not that powerful, they can't do anything. If someone is equally powerful, you both will fight with each other, right? So same thing is happening here. If your external voltage is greater than 1.1, then in this case we can say that this cell will be reversed. And this is one of a very important question, that if your external voltage is less than the voltage of the cell, starts working as an electrolytic cell. That means it is reversed. Reversed. The cell is reversed. We can say that electrons flow from cathode to anode and current flows from anode to cathode, right? Current will start flowing from anode to cathode, and electrons, opposite thing is happening here, right? Electrons are flowing from now, opposite will start happening, right? Because we have applied external potential which is more than the potential of the cell. This is from your NCERT, which is very, very important for you, right? Okay, students, clear? Now let's see who will tell me the answer for this one. If the salt bridge is removed, the voltage drops to 0. It's unchanged, increases gradually, increases rapidly. Let's see who is going to answer this question here. Murali, Ramaraju, Charun, Vaishnavi, very good. Blossom, very good, very good, very good. Don't worry, we are going to do a lot of numericals also, but in the starting now you have to understand the theory part, okay? Then we'll move towards the numerical also, right? So Ramaraju is saying B. Then Mohammed is saying increase. That is also increases rapidly, gradually. What? Increases rapidly. Okay, that means D you are saying. We are saying salt bridge is removed. I told you one thing. If you remember when I was teaching about salt bridge, I told you one thing. If salt bridge is removed, there will be on the anode side, if this is the anode side, this is the cathode side. Okay. What will happen? This will become highly positive. This will become highly negative. There will be, the charge will not be neutral. It will not be balanced. And that is why the cell will stop working. The cell will stop working at one point. That means the voltage will drop to 0. Right? So salt bridge, that's why it is installed. Because we want that the voltage, the cell should keep on working. But if one way you have positive, other way you have negative, electrical neutrality is not maintained. In that way, this reaction will stop, the reaction will not occur further, and the cell will itself stop working. That's why we are putting external potential, that is external thing, that is your salt bridge here. Okay. Oh, Paki, oh my God, one day though I can't teach you, right? For that, you have to see the one shots that are also there on this channel, right? But in detail, I would advise you, in detail, it is, one shots are for revision purpose. If you actually want to study in detail, then I would like advise you to like see detail, watch detailed lectures of every topic, right? That's why I'm covering every lecture in 3 to 4 parts, right? So that everything can get in your head, right? Okay. Yes, everybody. What are DPPs? Daily practice questions. Okay. Daily practice papers. These are DPPs. Okay. Now that answer is A is the correct answer. Now let's talk about the second topic. We have covered one thing, that is your Daniell cell here, right? Guys, if you have any questions regarding Daniell cell, then let me know in the chat box. If that is clear to everybody, then I would proceed with the next topic, that is electrode potential. But for that, I want to see your chats in the chat box, right? If that is clear, whatever I have taught you till now. Right, whatever I have taught you till now, if that is clear, then let me know in the chat box so that we can start with the next thing, that is electrode potential. It is one of the most important topics, right? And questions are asked based on electrode potential, right? Yes. See, potential occurs because of positive and negative charges difference. Okay. So what happens when you have positive charge here? When you have negative charge here, what will happen here? A potential difference will occur here. That is called potential. Okay. Now, potential difference created between electrode and its electrolytic solution. So, this is the electrode and this is the electrolytic solution. Okay. This is the electrolytic solution. Now, potential. See, we know that here you will have positive. And do you know also one thing, that it is connected to a negative thing? So I'll just show you that over here. See, what we have is, this is anode, right? This is cathode, right? This is anode, this is cathode. Firstly, tell me one thing. We are saying that anode is going to be negative, right? So here it will be negative. And we know that cathode is going to be positive, right? And we also know that when Zn is getting converted to Zn2 positive, right? So here in the solution, you will have a positive charge over here, right? And here when copper 2 positive ions are getting converted to copper electrode, this is getting thickened, and here in the solution you have negative charge. right? So what will happen for that movement? What will happen? You will have, because of the difference in the charges, say potential will occur anywhere where you have difference of charges, positive and negative charges, their potential will automatically generated, right? Now this is negative, this is positive. Yes, this is negative, this is positive. Here also you will have potential that is generated, right? Here also you will have potential that is generated, right? Now this potential is occurring on the anode side. This is occurring on the cathode side, right? And they are linked here like this. Okay, and here you have this salt bridge, and here you have this voltmeter, right? Now can I say, and here the electrons are flowing like this. Okay, now see this. This is called E naught of anode. E naught represents standard conditions. Okay, that means that standard conditions you have, you are taking this, you are making this setup, and the electrode potential at anode, the difference in the charges that you have generated, that is called E naught of anode, and here it is going to be E naught of cathode. E naught of anode is also called as E naught of left, and this is also called as E naught of right. Okay, right everybody? Understood? In the structure of atom, anode is positive, cathode is negative. Yes, this is what I told you. That in this is what I told you, in electrochemical cell, anode is positive. If you remember in the starting only, the first page I showed you that it's not like always anode is positive. In electrochemical cell, anode is negative and cathode is positive. That you should remember. Okay? Understood? Yes, everybody. In electrochemical cell, it is like this. Right? Now, let's understand this in more detail. Right? What is standard electrode potential? When concentration of all species is unity, 1 molar solution you have, pressure is 1 bar, that is called standard electrode potential, and standard electrode potential is represented by E naught. Right? Okay? Right, students? Clear? Anode, what is E naught cathode, what is E naught anode? If that is clear to all of you, then let me know here. Right? This is a cell. The difference is created between electrode and electrolytic solution. Because of that difference here, each metal and its solution will have its own electrode potential. Right? So on the anode side, it is called E naught of anode. On the cathode side, it is called E naught of cathode. Right? Okay. Now, very, very important things I'm going to teach you here, right? Very important and most confusing things that students feel. See, oxidation half cell will be at anode and that will give you oxidation potential. Okay. That means whenever you are calculating E naught anode, that is nothing but E naught anode oxidation potential. Whenever I am saying that here I am calculating E naught anode, right? So because at anode oxidation is occurring, I am calculating the oxidation potential at anode. This is very, very important. What I am saying, on the anode side you have oxidation. So that's why E naught anode is nothing but it is the oxidation potential of anode. But on the reduction half cell, what you have is cathode. So we are calculating the E naught cathode reduction potential. Okay. Let me know if that thing is clear to everybody or not. That at anode side we are calculating oxidation potential because it is losing the electron, right? And at cathode side, automatically from the experiment we are calculating reduction potential, right? Okay. Next is, according to UPSC naming, then you will say, ma'am, why we are talking so much about reduction? I'll tell you. This is conventionally it is taken that standard reduction potential is called as standard electrode potential, right? It's like when you fix something. So scientists have fixed that according to IUPAC, that if we are talking, if we are saying that standard electrode potential, calculate standard electrode potential. Standard electrode potential is, if you are saying that calculate E naught, that is nothing but E naught reduction potential. That means if we are calculating standard potential, electrode potential, that means we are automatically calculating standard reduction potential. This is by IUPAC naming. They could have also said that this is oxidation potential, but they have specified it to be reduction potential. Okay? Yes, everyone? Now, I know things might be confusing now, but just give it some time. Oxidation potential is negative of reduction potential. Always it is opposite. Now, I'll show you how. Right? Let's understand this point. Right? Wait a minute. Firstly, chalo, let's understand this point. Factors affecting electrode potential are nature of the metal electrode, right? I told you that every single metal will have their own reduction potential or oxidation potential, right? Concentration of ions, how much is the concentration of ions in the solution, and temperature. These three things will define the electrode potential, right? See, when the concentration of the ion is 1 molar, temperature is standard temperature you have. At that point, it is called E naught. But if you don't have concentration as 1 molar, you don't have pressure as 1 bar, you don't have standard temperature, then it will be E of cell, right? Then that will be E of cell. That's why we will have Nernst equation here. That's why we will study Nernst equation. That is going to tell you that how with change in temperature concentration, it is going to change the E cell. E naught cell is same for a metal. Why? Because we are specifying the concentration and temperature, right? Okay. What is E naught value is constant. E naught value is constant for a specific metal, right? But E value is not constant for a C. Students, you have two things, okay? So electrode potential is basically two things you have. One is E cell, one is E naught of cell, right? E naught of cell is nothing but standard. This is standard. That's why it is constant. It's constant for a metal. But E cell is, it can be at any temperature or any concentration. This is not constant. This depends on the, like, how you change the concentration temperature, this will change. Okay. Now, let's see the next thing. Give it some time. You will be able to understand. Now, I know that at this point, things might be confusing, but just give it some time. The potential difference created between two electrodes, cathode or anode, is called cell potential. Now, let's understand this thing. Okay? We are saying E naught of cell, calculate that. From this derivation, things will be absolutely clear to you. Okay, for this, you have to understand this thing. If you talk about E naught cell, E naught represents that we are talking about standard conditions, 1 bar pressure, 1 molar concentration, temperature is also standard here. We are talking about standard conditions. And here I am not saying that what is E naught anode, what is E naught cathode. I want to know in overall reaction, what is E naught of this overall cell, right? For that, we know that what we will add. Tell me one thing. E naught of anode plus E naught of cathode, right? So can I just add that E naught of anode plus E naught of cathode? So I'll just write that, because that is nothing but overall will be E naught of anode plus E naught of cathode. Now I told you one thing, at anode side there is oxidation happening. So that means at anode side the thing that we are calculating is nothing but oxidation potential. At cathode side reduction is happening, the thing that is calculating is reduction potential, right? Now see how you will generate this new formula. We know that according to IUPAC, I told you here that according to IUPAC, standard electrode potential, if you want to calculate, you'll have to calculate reduction potential here, right? So that's why I want to calculate E cell, right? So what I would want to do is I want to take everything in reduction potential, because IUPAC is giving more importance to reduction potential. And we know that I have also told you here that oxidation potential is minus of reduction. That means reduction is minus of oxidation. So can you write it here? Can you write it here? E naught of anode reduction potential is minus of this. So I have just put minus here, OP is changed to RP, right? Plus of E naught of cathode, and this is reduction potential. So can I say that E naught of cathode minus, this is also reduction potential, minus E naught of anode reduction potential, that is your E naught of cell. Now this is a very, very important relation, right? Very, very important relation that you are going to use throughout this chapter, right? That is E naught cell is equals to E naught cathode minus E naught anode. Usually students just cram E naught cell is equals to E naught cathode minus E naught anode. But here we are saying that E naught cathode reduction potential, and for anode also you are using reduction potential only, right? This is a very, very, very important thing, right? This is a very where students tend to make mistakes, because the questions will be asked based on Nernst equation. For that, you should know how to calculate E naught cell. Nernst equation I am going to tell you further classes, right? So for Nernst equation, it's not like very directly they will give you E naught cell, right? You should know how to calculate the value of E naught cell, right? Okay, is that clear to everybody here or not? Right? Now we know that cathode is also called right and anode is also called left. Some students learn it by right or left. I would advise you learn it by this: E naught cathode reduction potential minus E naught anode reduction potential, right? This way you are calculating the E cell. Okay. Now let's understand the representation of galvanic cell, because in the questions of Nernst equation you should know the representations also, right? So representation is also done by one simple rule, that is AC. That means this left part is called A, that is anode, and this particular part is called cathode. This particular part is called cathode. That means, can I say that here simply, how do you write the reaction here? Anode means loss of electron. So Cu is getting converted to Cu2 positive, right? And Ag positive is getting converted to Ag, right? Now let's see that how do you write this full reaction here. See, on anode side, what I told you that what is happening here. On anode side, I told you that on anode side you have loss of electrons, so Cu is getting converted to Cu2 positive. And then on cathode side, Ag positive is getting converted to Ag, right? This is what they have given in the cell representation, right? AC, this is always standard. AC, this is a standard thing, okay? Now, if you see this here, if I am saying that copper is getting converted to Cu2 positive, that means definitely this is 0, this is plus 2. That means this is on the side of anode. That means it is losing electrons. And how many electrons? 2 electrons it is losing. In this case, it is gaining 1 electron. So can I write it as like this? It is gaining electron. And can I just simply write it like this? Now, students, if you see this, this will be 2 electrons. I told you that electrons in a redox reaction, electrons gain and loss has to be same. So if 2 electrons are getting gained, 2 electrons will be lost. 2 electrons means here also it should be 2 positive charge, and then here also it should be 2 charge. Why? Because the 2 electrons will be gained. If I want to make it proper, this will be +1. 2 electron means -2 is equals to -1. This is not at all something which is right, right? So what I can do, if I multiply this by 2 and this also by 2, it will be +2 minus 2 is equals to 0, right? That is definitely right because here the charge is 0, right? So that means this is the correct thing that we have written here, right? Okay, so this is your reaction at anode side. This is the reaction at cathode side. Okay, so once you know the reactions of anode side and cathode side, see one thing, I am saying that it is going to be E naught cell is going to be E naught of cathode. Cathode is this thing. So what I will write it, E naught cathode. So whenever I am writing the reduction potential, I will write something that it is gaining. So Ag positive is getting converted to Ag, that is gaining. I will always write reduction potential. By reduction potential means always oxidation number is decreasing. So here +1 to 0 oxidation number is decreasing, right? So it is minus of E naught of anode. Anode is this thing. But should I write this thing Cu2 positive? Is it the right thing to write? Everybody, is it the right thing to write here Cu2 positive? Is it the right thing to write here? Yes, students, tell me, is it the right thing to write here or not? I can't believe you guys, huh? No response, nothing, huh? Cu2 positive is actually wrong here. Because in this way, Cu2 positive is actually oxidation potential. Here oxidation is happening. So even on the anode side, I have to write reduction potential. So I will write where reduction will happen, that is Cu2 positive to Cu. That's why it is written Cu2 positive to Cu. If I want to write Cu positive to this, then I have to add this here. But we are not getting into that. It's always E naught cell is equals to, you just remember that standard thing, that is E naught cell is equals to E naught cathode minus E naught anode. Cathode is given to be Ag. This is reduction potential, and here also write the reduction potential. This is converting from Cu2 positive to Cu. Oxidation number is decreasing. That means this is also your reduction potential here. Okay. Yes, everybody. Clear or not? Again, students have gone. What's the benefit of doing hard work if the students don't want to watch only? So let's do this. Why I am worrying about it? So it's totally your choice. You want to study or not? Your future. I can't do anything about it, right? All I can do is teach you in a better way, right? Okay. But the live watching, it is very, very disappointing to see that students are not at all interested in learning, right? I don't know how come I should teach by seeing you guys so less interested, right? Hmm? Chalo, no issues. Now, let's see the standard hydrogen electrode, that is SHE, right? In SHE, we always compare every single electrode potential because each metal will have an electrode potential. So, we know that, let's say you have two cases, okay? You have two cases. One is that this is your anode side, this is cathode, this is anode side, this is cathode. If you make hydrogen as standard, right? If you make this as your She, that means if you compare your metal by making anode as T, then you will calculate the, because this will be cathode, you will calculate the electrode potential, that is reduction potential here. You'll be able to calculate the reduction potential of your metal. Reduction potential of your metal, right? But if you're making your SHE, standard hydrogen potential at cathode, then you will, because this is your metal, metal is your anode now, right? So that means you will be able to calculate the oxidation potential of your metal. Okay, so that's why we are making a standard thing, that is SHE, standard hydrogen electrode, that we will compare with every single metal to understand their oxidation potential or reduction potential, right? So how come we will understand that? Let's see. Potential of individual half cell cannot be measured. We can't just say this is metal, measure its electrode potential. We have to compare it with something. We can measure only difference between two half cell potentials. So we need to compare. So what we take is, we take electrode half cell of the other being determined. How we take it? This is the hydrogen electrode potential that we take as 0, right? Of hydrogen everywhere, whether we are talking about hydrogen is getting converted to H2, this is also 0, or hydrogen H2 is getting converted to H positive, this is also 0. That means in case of hydrogen, this is nothing but this is the, because this is positive, 1 is getting converted to 0. 1 is getting converted to 0 means oxidation number is decreasing. That means this is nothing but when oxidation number is decreasing, tell me one thing, that is reduction or oxidation. We know that here, right? This is reduction. This is oxidation. So we are saying that whether you take SHE on the anode side or you take SHE on the cathode side, right? SHE, standard hydrogen electrode, on the anode side or on the cathode side, always it is going to be 0 electron volt, right? Always 0 electron volt. That means here SHE is 0 electron volt. Here also it is 0 electron volt. You have a metal, let's say I have zinc, okay? So I am comparing zinc and hydrogen, right? So now hydrogen I am taking as anode, right? Now this I am taking as cathode, okay? Now what will happen? This one I'll teach you here also with proper diagram. Na? Let's see this here also. That wait a minute. Where is that? Do we have that diagram? No, we don't have that diagram. Chalo, I'll have to make that diagram, right? Now, students, I'll make that diagram for you here, right? Let's see one thing. I am taking any metal, right? So, in that metal, what I am doing here, this is anode, this is cathode. This is anode, this is cathode. Okay. So, now, anode I am taking as, this is anode, I am taking as hydrogen. SHE, right? Cathode, I am taking as, let's say, anything you can take it as zinc or something. I am taking some M metal, right? So here, this is cathode. Here, cathode I am taking as SHE, and here anode I am taking as zinc, as metal. Okay. Now see one thing. So it depends that whatever you are doing in both the cases, things will change. The formula will change. We know that E naught cell is equals to E naught of anode oxidation potential. What is the oxidation potential of hydrogen? I told you that hydrogen has oxidation potential 0. Oxidation potential is also 0. Reduction potential is also 0. Right? Okay. So here we know that this is getting oxidized. So oxidation potential is also 0. Reduction potential is also 0, right? So here it is 0, right? E naught of hydrogen is in the oxidation potential. That means it will get converted to, oxidation potential means there will be increase in the oxidation number. So this thing minus E naught of This is metal. This metal is on the cathode side, so it will oxidation number will decrease here. So let's imagine that this has Mn2 positive ions, or you can say that actually Mn positive. This is metal, M is the metal. Okay, so here you will have Mn positive to M, right? Now we know that this will become 0 minus, so it will become nothing but minus of E naught Mn positive to M. Now see, you will see the same thing here also, right? So here also what we have, E naught of cathode minus anode, na? This is opposite we have written. Wait a minute, this must be opposite. It is cathode minus anode. This is the cathode part, so it would be E naught of Mn positive to Mn minus E naught of H2 to H positive. Right? Here things will be opposite. Here E naught will be nothing but that is going to be E naught cell is cathode minus anode. Now cathode is your standard hydrogen electrode, that is E naught of, here you have to write the electrode potential here, that is going to be, electrode potential is going to be H positive to H2 because oxidation number will decrease minus E naught of M to Mn positive. Because at anode side you are calculating the wait a minute, you want to write the reduction potential on both sides or oxidation potential. Let's add this only because we have written the oxidation and reduction potential like this. Okay. See what we have done, I'll tell you. We had two options, okay. So in anode side you write the oxidation potential of anode that I have written here, right? You for cathode you write the reduction potential of cathode, right? Okay. If you want to write it in a better way, you can just write that cathode reduction potential, anode oxidation potential. See, we know that this is also equals to 0. This is also equals to 0. So this will become equals to E naught of Mn positive to M, and this is equals to E naught of M to Mn positive, right? Now, can you see this visual difference here? Because here your Mn is the cathode side. So here we are calculating the reduction potential. And here this your metal is on the anode side. So here we are calculating the oxidation potential, right? So that's why oxidation potential is E naught of M to Mn positive. Reduction potential is E naught of Mn positive to Mn. So E naught, we know that E naught of Mn positive to M, that is, this is nothing but the reduction potential or oxidation potential. Bigger to smaller value. Let's say N is 2. So it will be plus 2 to 0. Right? So that means it is decreasing. That means this is reduction potential is equals to minus of E naught of Mn. Oxidation potential is this thing. Oxidation potential. Tell me students if that is clear. With H only, why H is constant? So we want to compare. So usually hydrogen is taken as constant for most of the things. For atomic mass calculation also previously hydrogen was taken as constant, right? So hydrogen is, because it is abundant also, it has the lowest atomic mass also. So that's why it is taken as, we have fixed SHE, that it is 0. So now we will compare everything with like SHE, right? So this you will calculate experimentally. This you already know. By this you can calculate the value of E naught Mn positive to Mn, right? Here also this you will calculate experimentally. This you know it is 0. From there you can calculate this value, right? So that's how you calculate the electrode potential, by comparing with the SHE, whether it's anode or it's cathode, right? So both, even if it is getting converted, it is oxidizing, let's say it is oxidation is happening, even then it is 0. On reduction also it is 0. I'll just write it here as well. E naught of H2 to H positive is also 0. E naught of H positive to H2 is also 0, right? Okay. Now, when we are doing this, right, the standard electropotential of SHE is considered as 0. Okay, Ji? Now, let's understand some questions here. Let's understand and do some questions, students. Let's do some questions, everybody. Okay, let's do now. Sure, if okay. So let's see. These two things are given to you. See, here we are about to calculate the what will be asked you in the exam. Okay. So calculate the EMF of Daniell cell. This is given to you. So whenever a cell representation is given to you, you always take this as anode. This is always AC. This is anode and this is cathode. Right? We know that E cell, E naught cell is nothing but E naught of cathode reduction potential minus E naught of anode reduction potential. So cathode is copper, right? So copper reduction potential. Copper is this thing. Can you see, is this reduction potential given to you? You have to see whether here reduction potential is given or oxidation. This is also AC. This is also AC. That means both the metal are actually getting converted from Cu2 positive to Cu. This is Zn2 positive to Zn. That means both the things that are on the cathode side, in both the metals, it is in the reduction phase. That means, students, when they're comparing copper with SHE, copper was the cathodic compartment. Okay, so copper, we are calculating reduction potential. That was coming out to be this. That means this is reduction potential only. And here also, zinc is on the cathodic compartment. That means it is reduction is going on here. That means this is also the reduction potential only. That means for both, they have given us reduction potential only. So we don't need to worry. Just put in the value of copper here. Copper is cathode minus anode. That means copper is 0.34 is the reduction potential minus of, this is minus 0.76 and it is going to be 1.1 volt is the correct answer here. Okay. Right. Oxidation potential of zinc, very good, that is 0.76. But you don't need to write the oxidation potential because the formula is E naught cathode reduction potential minus E naught anode reduction potential. So write down the reduction potentials only, right? Okay, and that will be your answer here. Now, let us see the electrochemical series. Don't worry, we are going to do a lot of questions based on that. But for that, before that, let's do the electrochemical series also. And this is going to be the last theory topic of today. After that, we are going to solve questions so that you know how to apply what we have learned, right? So, a list that describes, see what happened by comparing each metal with SHE, we have a list of electrode potentials that we have, where we have written it in the increasing electrode potential value, and electrode potential means we are talking about reduction potentials here. We are talking about reductions potentials here, right? This series has established by measuring potential of values electrode versus SHE, also known as activity series. So if you see, this is the series that we have. This is your reactivity series or the series of electrochemical series, right? Activity series, this is called. Now here, what we have observed is fluorine is the strongest. Ma'am, do I need to learn these values? No, you don't need to learn these values. I'll tell you how they will ask you questions based on the electrode potential, but you don't need to learn these values, okay? Now, this you should remember that fluorine is the strongest oxidizing agent. But before that, you should also know one very, very important thing. That is, wait a minute, one very, very important thing. That is, if I talk about reduction potential, This is very important. Reduction potential. More the reduction potential, more is the power to get itself reduced. Okay. That means if it wants to get itself reduced, if it wants to gain the electron, then it would want someone else to lose the electron. So it would behave as a very strong oxidizing agent. So that means the one which has very high reduction potential, they are very good oxidizing agents because they want themselves to get reduced and they want to oxidize something else. And if you have a very good reduction potential, we know that oxidation potential is opposite of that. That means oxidation potential will be less. If reduction potential is high, oxidation potential will be less. And if oxidation potential is less, that means they don't want to get oxidized. That means they don't want to reduce someone. That means they are a very poor reducing agents. They are very poor reducing agents. See, oxidizing agents are the one which wants to oxidize something. Reducing agents are the one which wants to reduce something. So the one which has high reduction potential will be very good in oxidizing something because it wants to get reduced and wants to oxidize something. But if it has a very high reduction potential, it has a very low oxidation potential. That means it does not want to get oxidized. That's why it does not want to reduce something. That's why it is a very bad reducing agent as well. Right? So this is a very, 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 very important thing. Mark it. This is very important. Most important thing. Okay? Very important. And based on this, I'll tell you how they will ask you the questions. Okay? So, now if you see this here, F2 has the highest reduction potential, right? That is the reason, because of very good reduction potential, it is a very strong oxidizing agent. More the reduction potential, more is the strong oxidizing power or oxidizing agent, right? And lithium has, this question can be asked to you, lithium has very low reduction potential. That's why it is a, when you have very low reduction potential, you are a very bad oxidizing agent. So it means it is a very poor oxidizing agent and a very strong reducing agent. Because if this is low, reduction potential is less, it's a very good reducing agent, right? Because they are inversely proportional to each other. So lithium is a very strong reducing agent and fluorine is a very strong oxidizing agent, right? Okay. Reducing agent value, there is nothing like reducing agent value, guys. There is reduction potential or oxidation potential. But this series is given on the basis of reduction potentials. So we are talking about that it has a very low reduction potential. That's why its reducing power is very strong, right? Okay. Okay, students. Yes, everybody. Yes, everyone. Devi, I'll surely take care of that, but please don't spam here, okay? Yes. Now, let's see the applications here. This I have told you that positive SRP, strong reduction potential means good oxidizing agent. Negative SRP means good reducing agent. This I have already told you here, right? You just need to remember this thing here, that which is directly and inversely proportional. Calculation of standard EMF value, this because see, when you know E naught anode, E naught cathode, you're able, see what is the benefit of calculating these reduction potentials. One thing is you are able to understand that which is a good oxidizing agent, which is a good reducing agent. Second is you're able to calculate the total EMF of any cell, right? So calculation of standard EMF of electrochemical cell. Third is predicting the feasibility of the reaction. This also is a very, very, very important formula that you will see in Nernst equation also. I'll repeat this, right? So delta G, see simple thing is when E naught cell is positive, then this is going to be positive. So this is going to be negative. That means it is going to be a spontaneous reaction. If it is negative, then this is positive. So it is going to be a non-spontaneous reaction. So by the value of E naught cell, see, once you know the value of E naught anode or E naught cathode, you can calculate the value of E naught cell. From E naught cell, you can tell that whether it is a spontaneous reaction or it is a non-spontaneous reaction. Okay? Yes, everybody? Yes, everybody? Clear, everyone? Okay, let's do the next thing, that is, let's do questions from where, see, understand one thing, physical chemistry is zero. In fact, nothing is there if you don't do questions, right? But if you start from the questions only, you have no knowledge about the theory, then also you are in loss, right? So theory with questions, right? So now we have completed our theory part. Now we are going to focus on what kind of questions they ask you from the topic that I have taught you today, right? So first is deduce from the following E naught values the half cells. What combination of two half cells would result in a cell with largest potential? We know that E naught cell is equals to E naught anode, sorry, E naught cathode reduction potential minus E naught anode reduction potential. So I would advise you, you have to write down the reduction potential of all of them, right? Write down the reduction potential of all of them. Or you know what I would advise you? So write down the reduction potential of all of them. Here, reduction potential means gain of electron. So here it is reduction potential. Here also it is given to be reduction potential. But in case of E and D, it is not given. So here, reduction potential will be equals to minus 1.5. And here reduction potential will be equals to 1.5. Right? Now, you have to take one of them as anode and one of them as cathode. I would advise you take cathode as positive and take anode as negative. Why? Because only, see, if I say that this is 5, this is minus of 5, then it will become 10. Na? So if you want to make this largest, then this has to be positive, this has to be negative. Only then the full value will be largest, right? So that means for cathode, I have positive values. Positive value is this value I have this value, I have this value. And out of this, the largest value is B. So I'll take the largest value. Largest value is largest positive value of reduction potential is B. Okay. And what is the anode means you have to take negative. And negative you have only this option, right? So negative you have only one option, that is A. So if I take this, this will be E naught cell is equals to 2.1 minus 1.5, that is 2.1 plus 1.5, right? Plus 1.5, that is going to be 3.6 electron volt, or you can just simply write volt, is your correct answer here. That is the largest value. So 1 and 2 you will use. So answer will be B is the correct answer. Okay. Yes, Sujay, there will be classes for class 11th as well, JEE 2027 as well. Don't worry about that, right? So 1 and 2, that is B is the correct option. Got it? How to solve these questions? Yes, everybody, right? Next is the standard oxidation potential for half cell reaction, right? For a half cell reaction, the standard oxidation potential is what? See, this is the half cell reaction. First, you have to tell me which one is cathode, which one is anode. Because we know that if you want to calculate the standard oxidation potential, beta, see, they're asking you to calculate the standard oxidation potential. So E naught of cell for oxidation potential will be E naught of, see, we know that standard oxidation potential E naught. We know that whenever we are calculating standard electrode potential, that is reduction potential. Okay, so that means if you talk about E naught of cell reduction potential is equal to E naught cathode reduction potential minus E naught anode reduction potential. Okay, now once you calculate this, E naught cell of oxidation potential will be opposite of E naught cell of reduction potential. Okay, let's see this here, everybody. Let's see this here. Now, if you see this here, we know that Fe2 positive is getting converted to Fe and Zn is getting converted to Zn2 positive. Here, oxidation number is decreasing. Here, oxidation number is increasing. This is the reduction part. This is the oxidation part. So, in the reduction part, what you have to do? Reduction part you have to take here, E naught cell of reduction potential is E naught cathode reduction potential. So if you see this here, this is the cathode side, this is the anode side. That means Fe reduction potential you have to take. In both the cases, oxidation potential is given to you. So you know what I'll ask you? Try to convert this only. We know that E naught cell of oxidation potential is minus of E naught cell of reduction potential, which is minus of E naught cathode reduction potential plus of E naught anode reduction potential. Now, if you see this here, can you just write it as this is E naught cathode oxidation potential minus E naught anode oxidation potential. Can you derive this thing also from here or not? Can you derive this or not? E naught cathode oxidation potential minus E naught anode oxidation potential. You can directly do that. It's not that of a big deal, right? So E naught cathode oxidation, either you do this way or you can directly do this. Okay? Either you do this way or you can also do this way. Okay? If you are like, ma'am, this is also not that good. That's why I told you these things you have to be clear on this, right? E naught cell of reduction potential. This is why IUPAC naming that we got standard reduction potential is electrode potential only, right? So this is E naught cathode of reduction potential plus E naught anode of oxidation potential, right? Now we know that E naught cell of oxidation potential is opposite of E naught cell of reduction potential. So first you just calculate the reduction potential here. See, this is your cathode, this is your cathode, this is your anode. For cathode, write down the reduction potential. Reduction potential is nothing but it is, reduction potential means this is oxidation potential. Reduction potential will be E naught reduction potential of cathode will be is equals to minus of 0.41. So you just write minus of 0.41. This is positive. This is E naught anode. This is 0.76. And here they have lost the electron, so oxidation potential is given. So this is 0.76. Right? So 0.76 minus 0.41 is your E naught cell of reduction potential. Right? And E naught cell of oxidation potential will be opposite, that is minus 0.76 plus 0.41. That is your oxidation potential. Yes, everybody, right? Ma'am, EF is the only, here they have mentioned, that's why I have told you this now. That's why beta I have told you this. E naught cell, 2-3 things to remember. E naught cell represents overall cells reduction potential. This is by IUPAC name, right? By IUPAC, they are saying that E naught cell is nothing but it is equals to E naught cell of reduction potential only, right? And here it is E naught of anode oxidation potential plus E naught of cathode reduction potential. Okay, right? Now, this is nothing but minus of E naught of anode reduction potential plus E naught of cathode reduction potential. That's why we usually write E naught of cathode reduction potential minus E naught of anode reduction potential is your E naught cell, right? But here they are asking you, they are asking you standard oxidation potential, right? So here you are calculating the standard reduction potential. You can use E naught cathode minus, okay, you don't want to do this, fine, right? You do this, you do it this way. E naught cell is equals to E naught cathode reduction potential minus E naught anode reduction potential. Reduction potential of this and reduction potential of anode is nothing but that is minus 0.76. So you put it here, cathode is this thing, that is minus 0.41, minus of this is minus 0.76. So that is nothing but 0.76 minus 0.41. That is the E naught cell of reduction potential. Okay. But here they are asking you the oxidation potential. That is minus of 0.76 plus 0.41, and that will be your answer. Okay? Yes, everybody? Now got it? Right? Okay? So that's how you should solve this question. Next is, in a cell, the following reactions take place. These are the reactions. Some cell is there. The standard electrode potential for spontaneous reaction is this. Spontaneous reaction. Standard electrode potential you have to calculate here. See, E naught cell is equals to E naught of cathode minus anode. Now, can you tell me which will act as cathode, which will act as anode? Now, that is the main question here, okay? So, this is plus 3 to plus 2. That means here they have given reduction or oxidation potential. Don't focus what is given. Just see plus 3 to plus 2 means oxidation number is decreasing. That means this is the reduction potential. Here also 0 to minus 1, it is decreasing means this is also the reduction potential. Now, the one which has higher reduction potential will act as cathode. Okay, the one with high reduction potential is acting as the cathode. So that means this will act as cathode and this will act as anode. Okay, this will act as anode. Now what you have is E naught of cathode reduction potential minus E naught of anode reduction potential. E naught of cathode is what? This is reduction potential is 0.77. Here anode reduction potential is See, don't look at these reactions, okay? This is just to confuse you. In these reactions, they have given loss of electron, but here they have mentioned reduction potential. So don't look at these reactions and say that this is oxidation potential. You have to look for this thing here. Here, oxidation number is decreasing, right? So that's why both are reduction potential. This is 0.54 and this will become your answer here. Okay, students? Okay, students? Everybody? Everybody? Right? This will 0.23, that is 23 into 10 raised to power minus 2. So answer of x is equals to 23. Okay? Chalo, very good. Now, next question is, you have at 298 Kelvin, The standard electrode potential of copper 2 positive, this, all of them are given to you. On the basis of standard electrode potential, predict which of the following reaction cannot occur. Okay. See, reduction potentials are given now. -2 to 0 reduction, +2 to 0 oxidation number is decreasing, +2 to 0 oxidation number decreasing, +1 to 0 oxidation number decreasing. That means all of them are reduction potential. This is of copper, this is of zinc, this is of iron, and this is of Ag. Right? So that's how reduction potential will be given to you in the question. You just have to see whether they have given reduction or oxidation potential. On the basis of standard electrode potential, predict which of the following reaction cannot occur only. Okay. You have to see which of the following cannot occur. Yes, everybody? You have to tell me which of the following cannot occur. So this is a displacement reaction. The one which has high reduction potential can displace with lower reduction potential. So Ag should have higher reduction potential as compared to copper to have this reaction. So Ag is the 0.80 and copper is 0.34. So this reaction will definitely occur because here Ag has more reduction potential as compared to copper. Zinc should be more than copper. Zinc is actually less than copper, so zinc cannot displace. So zinc is less than copper. You can say copper is more than zinc, so that's why this reaction will not occur. Iron should be more than copper. Iron is also not more than copper. Right? Wait a minute. Predict which of the following reaction cannot occur. Wait a minute. Standard reduction, which is the following. Zinc should be higher than iron. On the basis of standard electrode potential, a reduction potential is given, na? Yes. See, reduction potential is given. My bad. Reduction potential is given. Reduction potential means the tendency to gain the electron, right? But here Ag is getting converted to Ag positive. That means it is losing the electron. So its reduction potential has to be lower. Metal should have here, zinc is getting converted to Zn2 positive. That means it should not be able to gain, it should have the tendency to lose the electron. Here iron is getting converted to iron 2 positive. That means this iron should have tendency to lose the electron, right? This zinc should have tendency to lose the electron. That means they should have, metal should have high tendency to lose electron. That means high oxidation potential. That means low reduction potential should be there, right? We are focusing on low reduction potential, okay, not the high reduction potential. So this Ag has low reduction potential as compared to copper? No. Ag has more reduction potential as compared to copper. So Ag would not want to lose electrons. So that's why it will not get converted to Ag positive. So this reaction will not happen. Zinc has less as compared to copper. Can you see? Zinc has less as compared to copper. That means this reaction will occur. Iron also has less as compared to copper, right? And Fe also has less as compared to copper, right? Sorry. Zinc na, end mein we have zinc as compared to iron, okay. Zinc is this as compared to iron is this. Zinc has low, yes, zinc has low as compared to iron. So all these reactions will happen, but this first reaction will not occur. So answer is A is the correct answer here. Okay? Understood, students? A is the correct answer here. Next question is, on your screen we have, will iron be oxidized to Fe2 positive? by reaction with 0.1 molar HCl. See, standard condition is given to you. They are saying that will iron be oxidized with iron 2 positive be oxidized here. Oxidized means getting converted to this, right? Now, for this you need to understand that E0 cell has to be positive. Only then delta G will be negative because delta G is equals to minus NF E0 cell. So if delta G is negative, only then this reaction will be spontaneous and hence feasible. So you have to check whether E0 cell is positive or not, right? So to have the E0 cell positive, you want to oxidize, Fe be oxidized to this. So you have Fe, it is oxidized to Fe2 positive. You have HCl here, right? So this is converted to, let's say, in this case, this is oxidation number is increasing. So oxidation number increasing means this is oxidation part, right? And the other will be the reduction part, that is HCl being converted to H2 here. That you have your HCl that is getting converted to H2 here. This will be the reduction part, okay? So here this will be converted to H2 here, right? And we know that because this is in +1 state, +1 to 0, that is decrement, that is reduction. Okay. Now we know that E0 cell is equals to E0 cathode reduction potential minus E0 anode reduction potential. E0 cathode is this thing. What is cathode? This is cathode and this is anode, right? E0 cathode is this, and here you have reduction potential, that is 0, minus what is the reduction potential of this thing? Tell me, is this the oxidation potential or the reduction potential? 0 to +2, that means oxidation number is increasing. They have given you oxidation potential here. Reduction potential will be equals to minus of 0.44 volt. So we'll put here reduction potential 0.44. So answer will be 0.44 volt, that is positive. That means this reaction will be feasible in nature. Okay, that means this particular reaction is going to be feasible in nature. Right, everybody? Next is your JEE 2024 question, that is standard reduction potentials are given to you. For the following half cells are given below. They are saying consider the given electrochemical cell, the number of metal which will be oxidized by this. Now these kind of questions are very, very important for you, right? Easily you can do this. So what they are saying, number of metals which will be oxidized by this. So if this is oxidizing something, oxidized, which will be oxidized by, this will be by this oxidizing agent. So that means this is causing oxidation. That means the other metal has to lose the electron. Metal has to lose electron. Okay. The number of metals which will be oxidized by this, that means oxidize, it's a very good oxidizing agent, it will cause oxidation. That means the metal has to lose the electron. That means the metal has to have very high oxidation potential. It has to have low reduction potential. So it should have low reduction potential as compared to Cr2O72 negative. If its reduction potential is lower than that, then this will itself get reduced and it will oxidize something, right? So its reduction potential, you can see here, the reduction potential of Cr2O72 negative is E0 of this. Can you see, is this the reduction potential? First you have to check whether this is reduction potential or not. So if you see this, this is 2x minus 14 is equals to minus 2, that will become plus 12, that will become plus 6. So here oxidation number is plus 6, okay, and here you have plus 3. So definitely oxidation number is decreasing, that means this is reduction potential. And here also all of them are reduction potential only. So I need to find the value which is lower than 1.33. This is lower than 1.33. This is lower than 1.33. This is lower than 1.33. But AU is not lower than 1.33. So you will have three metals that will be oxidized by this. That is iron and nickel, and you have silver. Okay, gold will not be oxidized by the potassium dichromate solution. Okay, same kind of question, one more question we have, that is asked in JEE 2023. So repeatedly 2 years they have asked the same question, right? That is, the standard reduction potential for the following half cells are given below. So here it is gaining the electron, that means it is definitely reduction potential, and they have also mentioned that this reduction potential they have given, right? Now they are saying that this reduction potential is also given to you. Now they are saying that which of the following number of metals which will be oxidized by NO3 negative. If NO3 negative wants to oxidize something, that something has to have a high oxidation potential. That means low reduction potential as compared to NO3 negative. So that means the reduction potential, that means this value has to be lower than 0.97. This is lower, this is lower, this is also lower, this is not lower. So answer is again 3, that is vanadium, then you have iron, then you have silver. Okay, these three are getting oxidized by NO3 negative. Right? Okay, everybody, that is clear. I'm very happy that you're finding this easy, but usually students don't find this chapter easy. Right? Now, next is the spin only magnetic moment value of M3 positive ion. This is your JEE Mains 2022 question. This is slightly related to something else also, your inorganic chemistry also. So spin only magnetic moment, they are saying mu is equals to, we know that, under root n plus 2, Bohr magneton. Now they are saying moment for M3 positive ion from the pairs has negative standard electrode potential. Now firstly, you should know that which has negative standard electrode potential. Which has negative standard electrode potential, right? So electrode potential negative is for, negative, E naught cell negative means delta G is positive. That means that change is very difficult to happen, right? So chromium 3 positive to chromium 2 positive is a difficult change. Fe 3 positive to 2 positive is easy, 3 positive to 2 positive is easy, cobalt is also easy. Chromium is actually having a negative E cell value among them. So that's why we want to calculate for chromium 3 positive here. Right? And they are asking about M3 positive ion, that means chromium 3 positive. Chromium is nothing but it is Saktivkar, that means 24. So it has which, what is the electronic configuration? This is 4s1, 3d5. So when you take out 3 electrons here, it will become 3d3, right? So that means number of unpaired electrons is going to be 3. So mu is going to be under root 3 plus 3 plus 2. That is nothing but 3.9 Bohr magneton, right? What is the unpaired electron? Just put 9.8.9 after that, you will get the number. And this thing, how to calculate magnetic moment, this we will study in coordination chemistry in detail. Right now, just I have given you a formula and I'll tell you that how it is becoming 3.9. Okay? Yes, everybody? Yes. If nearest integer is 4. So answer will be 4 is the correct answer here. Okay? Yes, students? Now, last question that was asked in JEE Mains 2021, that is, these are physical properties of element. These are given to you. The total number of above properties that affect the reduction potential. Now, I don't expect that you guys can easily answer this. I'll tell you. Usually students, most of the students mark this wrong, right? Sublimation enthalpy, ionization enthalpy, hydration enthalpy. These three properties affect the reduction potential. Electron gain enthalpy will not directly affect. Usually students think that electron gain enthalpy will affect. But in reality, electron gain enthalpy will not affect it directly because it's about reduction potential is about overall thing in an environment, in a chemical equation. But ionization enthalpy, hydration enthalpy, and sublimation enthalpy will affect it, right? So answer is going to be A, B, C. That is 3 total properties will affect it, right? Okay. Yes, everybody. So that was your last question, and now you have your homework. This is the homework number, question number 1. SOP means standard oxidation potential is equals to which of the following, right? Minus of oxidation potential, minus of standard reduction electrode potential, minus of SHE, or none of above, right? I think this you can easily answer if you have actually studied what I have taught you in the lecture, right? Then second is, this one is oxygen having positive standard potential means a good oxidizing agent, good oxidant, bad reductant, or none of them, and one or more can be the correct answer in this, right? Okay. Yes, everybody, mark this. So that's it for today, students, and this is our official Telegram JEE channel, right, which you can subscribe for the live updates, and I am waiting for your homework. But before that, I also want to know that if you want me to give you DPPs of solutions or chemical kinetics or not, along with the homework, you can write it down. You want it separately or mixed, right? Now, you can see this here. This is Sigma JEE batch, students, where the syllabus is already going on, right? Students are totally in love with this particular batch, right? And this is just at 4,999, where we are providing you live classes, replay doubt session is provided to you, leaderboards, quizzes, mock tests are taken, test series are provided. These kind of really interesting quick scanner cards are provided to you. If you see this here, these kind of quick scanner cards are provided to you, really interesting, so that you can have your revision. Test series are provided. So everything is provided at just 4,999 here. You can view this course plan, and accordingly you can choose your plan, right? At 4,999 you will get everything that I told you. You will have test series, mock tests, everything, the live classes, doubt sessions, everything. But if you want to have the JEE quick revision cards, that is these cards, right, then you will have to buy this for 5,999, right, where JEE quick revision cards are also provided to you. And if you want to have Tattva JEE 11th and 12th books in the hard copy version, then students, you have to go for this 8,999. That is where, see, Tattva books will be provided in all of them. It's just that here that will be provided in the hard book format. That means it will be delivered at your house, right? Otherwise, here PDFs will be provided to you. Okay? Okay, just fine. Definitely, I'll make that for you. Don't worry, right? Okay, then, students, bye-bye. Take care. See you all in the next class, and don't forget to do your homework because I am waiting for your homework, and share this video with your friends, and I want full attendance in the next class. Otherwise, the energy of the class really drops, right? So if you're watching this on the recorded version, then do let me know why you're not coming in the live class and watching this on the recorded version. Is there some timing issues or whatsoever? You can write it down in the comment section, right? Okay then, students, bye-bye. Take care. See you all in the next class.